Today I'm going to make a few files available to you. We'll start with them in this video, and I'll have the files in PDF form available to you as well. This will be going over that 2000 F350 that was in the shop right before you all left, some of the weird electrical problems that were happening with it, and what we eventually found wrong. What I'm wanting you to see from this, and I'm sorry that the camera was so shaky, but I was wanting you to see the point of entry where that water contamination came in. We were looking right behind the dash where the windshield and the dash come together at that left front A-pillar. That's the harness right there that hooks up to that central junction block, and the wires that are coming down, I saw nothing in the wires to lead me to think that it was coming through at a super strong rate, but as it turned out, it was just enough over time to create that contamination that we saw. Now these two plugs right here are for the GEM module, the generic electronic module, which plugs in on top of the central junction block and then feeds directly into it, and that's why we were getting a whole lot of timeout issues that were backfeeding through this junction block. When you're looking at the wiring diagram, note that when you're looking, it will designate the white and give you the number of pins in the plug, and it will say the brown plug with the number of pins there. That makes it easier for identification, and you can then look at your pins and correspond with your wiring color codes. And again, this is trying to give you an area where we were working at the corner A post, trying to locate if it was a windshield entry leak of water, but it turned out it was not. When it comes to a water entry problem, we always have to work with gravity, and gravity, I've said it before, it is such a fickle mistress because it doesn't matter. That water's going to find the lowest point, and any small leak can give you trouble. So I followed the trail from the third brake light looking around, and I was able to then pull down the headliner, and I was to see some of the water trails coming in off the lights that were mounted on the cab, and I trailed that down and I saw this seam sealer. So I tried to get a shot of this where I'm pushing on the seam sealer, and you can see the looseness of the foam behind it. I switched up and used a screwdriver to pull some of that away more, but what it ends up being is I believe it was the cab lights that were creating our water entry problem. So getting up and sealing those and then putting a bunch of dielectric grease in the wires ended up, I think, being the solution to the problem. So what exactly did the problem look like? How did we identify what was going on? We started with symptoms, and then we looked back at our PowerPoint starting point. The primary customer complaint was occasionally when they shut the truck off, the blower motor would continue running. They could turn it off at the blower motor switch, but if they forgot to turn that blower motor off, they could come out the next morning and the battery'd be completely dead. When they hooked up to give a jump start, somehow that blower motor had turned itself on, and that was because they left that in the on position. So when the customer left the blower motor in the on position, just shut their truck off like we all do, when the truck shut off, the blower motor went off, they didn't think anything more about it. But as you can see in this image, the circuit had a short to it to power, which it could power on that generic electric module and a variety of other things that would create the short circuit to power. So breaking down that fuse block, what I want you to see here, taking it apart, you can see the numbers and the pathways that are molded into the plastic. And then I'm going to show you some of the electrical connectors that are layered inside here, and they have corresponding numbers to the pathways. So this one would lay in number 18 that is down there, this one number 13, and I found that trying to repair this was going to be tricky because you can see the little plastic areas where they've heated it up to hold those in place. So the option was get online and see what we could find, and we did find a good used box. It was $120. It came out of Texas, and coming out of Texas is an important thing, because when you see this image, when I flip it over, you're going to say, man, that one's rusted up too. But as it turns out, that's not the case. If you look down where the plugs are and around the box, that's not the case at all, and that all has to do with location. Northern Texas and Oklahoma has a real red dirt problem that can kind of look confusing, and that's what this turned out to be. So what I did was I got some electric parts cleaner, and we cleaned the dirt out of this and made sure we had a good connection. I used the CRC electronic cleaner and some swabs to get in there and get that red dirt out. I did use a blowgun to help delodge some of that dirt, and then what I was going to do is I'm going to get in and I'm going to use the dielectric grease. I'm going to clean out the plugs. I'm going to fill those with the dielectric grease, and I'm going to put some of that dielectric right there where the gym module plugs in. There's the company that we got this from. Came with a 90-day warranty being used, and we'll get that installed and see how everything works.